All right, everyone, we are ready to start our next presentation. So take a seat. You guys can move up too. Don't be scared of each other. Cool. All right, I would like to introduce our next speaker, Dr. Jackie Faherty.
Hi, everybody. I think this is on. I'm your last speaker of this official program, though there's a panel after this for you guys to stay for. And hopefully this will be lively. I want to see people excited and happy, and maybe recruit a couple of you guys to participate in the citizen science project that I'm going to tell you about. So my talk is about a project that's called Backyard Worlds, Planet 9. And this is a Zooniverse project. We have a Zooniverse site. You can all go and log on to it after you take a picture of this. Log on to it after you finally get convinced after my talk that you want to participate. But I'm going to tell you what this whole project is about and the kinds of things we've accomplished, as well as the kinds of things that our volunteers have gotten to do with us. And that's kind of my hope, that it gets you inspired, that you want to participate in a project like this. The subtext to our project is you can help scan the realm beyond Neptune, the current 8th planet in our solar system. 8th planet? Oh my goodness, yes. For brown dwarfs and Planet 9. And I'll tell you what brown dwarfs are as part of this talk. But I want to also intro you to the other collaborators I have on this project, because it's important to acknowledge all of the people that are a part of things. There are 4 of us that founded this project. The 3 others that founded it with me are on the left: Mark Kushner, Aaron Meisner, and Adam Schneider. We're at different institutions, but we came together as a group with a shared desire to invite the public to come search the skies with us. Mark is actually the ambassador for NASA for citizen science. He's a really good one to know. You can write his name down, write him, ask him questions. Mark is readily available to everybody that wants to do a citizen science project. And then we've got a pretty large scientific team that also is part of this project. So let me explain the motivation behind Backyard Worlds, Planet 9. Quick question. This is audience back and forth here. Who knows what the closest star is to us? Just shout it out. I knew you were going to say the sun. It happens every time, and I accept. After the sun, what comes next? I heard both Proxima Centauri, and then, did I hear Alpha Centauri? So Proxima Centauri system. All right, now it's getting harder. What's after Proxima Centauri? Alpha Centauri is in a triple system. It's got Proxima Centauri and Beta Centauri. But after that system, the next system is called Barnard's star. You were so close. It's a very fast-moving star. You didn't get second, so I don't think you're going to get third. Third closest system to the sun. I'm sure you don't know. Yeah, well, Brian, you're supposed to know these. Yes. Professor of astrophysics here at Boise State has got it, nailed it. So actually, Brian and I were postdocs together when this result came out. I don't know if you remember this. I was freaking out down the hallway because the closest systems to the sun, the stars that are closest to you, or whatever it is that's closest to you, it should really not, we shouldn't be finding new ones. Do you understand what I'm saying? It's like waking up, turning over, and seeing, oh, you lived with me this whole time, and I had no idea you were there. Like, it's insane to think you could find a new object. Barnard's star, Proxima Centauri, those are systems we've known for a century, more than a century when it comes to Proxima Centauri and Alpha Centauri. The third closest system to the sun, this Lumen 16, it's also called WISE 1049A and B, was discovered in 2013. So maybe we weren't postdocs together at that point, but 2013, that's not that long ago, guys. Everybody here was alive, yes? We don't have any of the small ones here anymore. And then a year after that one, another discovery. Yeah, right? Another system. We had no idea it was there. And so when that happened, I freaked out. I was like, there might be more. Maybe there's more. What if there's other systems in our backyard? So this is a little video that I made that shows you the sun, Alpha Centauri and its system, Barnard star, and then these two objects there. One of them called Lumen 16AB, and the other one is called WISE 0855. Just quick question. Has anybody read the book, The Hail Mary Project? A couple of you guys have read Hail Mary Project? Yes? I don't want to spoil it for anyone, but if you should read it. It's fun. It's going to be turned into a movie. Ryan Gosling's going to star as the astronaut. But in that book, the author, who's the author of The Martian, writes this story of something that's happening to our sun that gets infected by other objects. And he writes this pretty extreme story. And in the story, he says the sun is infected by this other star called WISE 0855. Now, first of all, it's not a star, guys. It's not a star. It's so cold, we didn't see it until the year 2014. We didn't know it was there. The reason we missed it is not because we weren't looking or somebody kind of looked the wrong way. It's because it's cold, and you have to look in the infrared to find it. And infrared surveys are rather new in astronomical study terms, and we needed a survey that NASA has called WISE, or the Wide Field Infrared Survey Explorer. WISE was launched in 2008 or 9 maybe, and it was releasing a catalog in 2010, and that catalog was the entire sky at mid-infrared wavelengths that we'd never seen in an all-sky survey before. And what happened was there was one guy actually, his name is Kevin Lumen, which is why it almost sounds like, does anybody remember Seinfeld? He would always say Newman. This is how I say Lumen. Lumen did it again, twice. Single author papers. What he did is night after night after night, as an isolated human being, he blinked images. He blinked the images of the sky in these mid-infrared wavelengths, searching for things people hadn't found before. And in doing that, he revolutionized our idea of the solar neighborhood, finding the third and fourth closest systems to the sun. So when I saw Lumen 16AB, I was like, oh my God, what else could be there? And then when WISE 0855 came out, I was like, there's something closer than Alpha Centauri. Thus sprung my desire to find something in our backyard that we had not found before. And Mark Kushner, the guy I was telling you about that's the NASA ambassador, came to me and said, why don't we make that a citizen science project? And so we have. So that's our project, scanning the skies in search of the previously missed neighborhood members. We're making a map of our neighborhood like never before. Now I'm just going to explain this object, WISE 0855, for you for a second because it's so good. So why is it such a good object? I'm going to zoom in on an image of it. So this is an image of it taken in the mid-infrared in this WISE survey. So it's an image of the sky. It's a small field of view. This is maybe like 2.5, 3 arc minutes on the side, something like that. There it is, that object that's dotted there. And the important numbers is that it's just 7 light years away. If you're going to get on a spaceship and go somewhere, you're going to hit that one pretty quickly. It's the fourth closest system to the sun. So when Earth has a problem, we need to go elsewhere, this is going to be one of the objects that you're going to go look for. It's why this guy wrote about it in the Hail Mary Project. Notice that temperature. It's a frigid temperature, 225 to 260 degrees Kelvin. Jupiter, folks, is about 125 degrees Kelvin on its surface. This thing is 100 degrees plus warmer than it, But here's the difference. It does not have a host star. It's not orbiting anything. It's all by its lonesome. Isolated little rogue world out there. And look at the mass of it. 3 to 10 times the mass of Jupiter. 3 to 10 times the mass of Jupiter is so small. This thing is, for lack of a better word for it, a rogue world, an isolated, orphaned world out there. It's frigid, it's cold, and it's really exciting to consider that there might be more of these kinds of objects out there. Myself and others did a lot of studies on it. We had several big studies on this particular object, and it's so cold, you can have water ice clouds on it. So you can actually have this kind of frozen ecosystem in its outer atmosphere. Jupiter has it too. You can have this kind of frozen ecosystem, which is exciting to think about. Now, I'm not telling you can have aliens living in the clouds of one of these worlds, but somebody else wrote a paper about that. I didn't, but there are others that have thought about that. Even Carl Sagan, the great science communicator, wrote a paper postulating about what might exist in the water clouds of Jupiter. So aside from the fact that it's just mapping the solar neighborhood, these objects are critical objects to study for our understanding of atmospheres in general. And then there's this really exciting thing to think about. If you look at the whole census of just about 32 light years away from you, we pretty much have found all of the big stars. We found them. They can't hide. You can't hide an A star. They're so bright. You're going to walk outside and see that. You're going to see the F stars. You're not going to hide the sun. We're going to find those kinds of objects. K types and M types, we basically got those two in all of our all-sky surveys. But it's these things called brown dwarfs that are so low mass that they actually don't have a nuclear burning engine at their cores. So stars light up because they have enough mass in order to get their core hot enough where stable nuclear fusion can happen. But in the case of a brown dwarf, it doesn't have enough mass. And that happens at 75 times the mass of Jupiter. So that's our playground. Things that are 75 times the mass of Jupiter and lower mass than that can hide in the solar neighborhood. You cannot find them, and then you won't know all of your neighbors. And excitingly enough, there was this result that came out of a microlensing team. It was 2011, and they were doing a scan of the skies using this technique called gravitational microlensing. And the results that they found hinted at the idea that there were billions of wandering isolated planets in our in our galaxy. That our galaxy could be teeming with isolated worlds like that 0855 object. And so if that's the case, maybe some cold ones were sitting there waiting for us to discover. Hence was launched our Backyard Worlds project. So what did we do? We decided to take those NASA WISE images, that whole area of the sky that was mapped in the mid-infrared, and it was mapped not just once, but WISE scanned the sky and then returned and scanned it again. And when you do that, you've got a time baseline in between your images. And what we did was what Kevin did. Kevin sat there just looking at images by himself, and we set up an interface that anybody could do it. So that's the discovery of WISE 0855 that we found in our project called Backyard Worlds: Planet 9. So, that might have broke sorry guys. The orangeness of that object is really important because it's telling you something about the kind of object that it is. The orange is a result of us subtracting 2 different wavelengths of light. So on one side, the NASA mission looked at one side of the mid-infrared wavelength. It was at 3.5 microns. That's just a wavelength of light. And then it took another set of images at 4.5 microns. And if an object had more light coming out at the 4.5 micron, it's going to look orange. And you want it to be orange because the more light that comes out at the longer wavelength, the colder the object is. So what we asked our citizen scientists to do is look for jumping orange dots in the entire WISE survey and scan, and let's see what you find. I'll give you a little idea of who worked with us. We launched, you might have noticed, did you catch that I said it was Backyard World's Planet 9? Did you catch that part? Yes? Okay, so that was our hook in some ways, because in scanning the skies, by looking at images taken after a certain amount of time passes between them, you can see things that move. And they move because they're nearby to you. Things that are close to you, you can actually detect their motion through the galaxy. All the stars are moving. We're moving right now. The sun is taking us with the planets all through it on this galactic journey that we're on. And all the stars are on a galactic journey. The closer the stars are to you, the more you can see that motion. We call it proper motion. And the proper motion you can see when you blink images. It's the technique, we call it the blink method. That's how Pluto was discovered, which is why you could also find another planet in our solar system, if it exists, using this same method. Now, our hook was to get people excited to find Planet 9. I don't know for sure that there's a 9th planet in our solar system. I'll just say that straight up. But if there is one, this is one of the methods you could use to find it. And lots of people got excited when we launched. We immediately had thousands of users. Here's a map of where our users come from. We have 50,000 registered users now. There's 140,000 unregistered users, and we have what we call 50 super users. This is what I would invite you to try and become. Our super users spend a lot of time with us, the researchers. We talk to them about things nonstop. They do calls with us. And they're the ones that are probably getting the most out of the project. Not to say that you can't just be a regular user and get a lot out of the project, but you're not going to have as much interaction with the researchers. Our super users end up doing lots of side projects too. And here's a little image I took of one of our calls. So we do weekly calls, and we invite all the citizen scientist super users to join us. You might be wondering who this lovely face is in the middle. This is a high school student that's a part of it. His name is David Black. And David was calling in from his high school lunch period. And he happened to be speaking when I took the shot, so that's why David's up front and personal. But anybody calls in with us, that's me up in the corner, Adam, one of our other co-founders. It was a lot more people here, but these are the ones you get to see. We've got volunteers from Argentina, volunteers from France, volunteers from Mexico, volunteers from Japan, and they all call in at different times, so our time zone ranges the whole thing for people that are volunteering to help scan the skies with us. The way that we work is that you log on, you blink the images, and that if you see something, you click on it and it sends it to us. But there's a second way for you to participate. We have a user forum, and you can fill that out. You can go on the Zooniverse site and fill out something about yourself, but you could also talk about an object. That gets sent to us as well. And then we have another special form, if you get super into it, where it goes straight into this form we've sent to all of our users called the Think You Got One form. And that we talk about all the time on our research calls. So if you were to log on to the site, you'd see this tutorial that would help you figure out how to look for an object of interest. Now, there's millions and millions and millions of tiles to look through, and so it's a lot of eyeballs that we've been asking for. And frankly, I get asked all the time, why don't you just do catalog searches, or why don't you use machine learning? And we have done that too. We've done machine learning. We've done really complex algorithms. And sometimes they find stuff that the users have never found. But sometimes the users find stuff that the algorithms never found. You need both. Believe it or not, the human eye is amazing at pattern recognition. And that's essentially what you're doing when you help us blink the sky looking for small orange dots that jump around. So I'm going to show you a little montage of some of our discoveries. So these are little cutouts of some of the discoveries that have been made. So I don't think I have a laser pointer here. So everybody take a look. These are some of the easier ones. Look for the orange dot. Can you see an orange dot jumping? And each one of these is a cutout. Each one of these is a cutout and shows you a dot blinking. So like that dot from image to image. These are taken over time, and so every image is taken with a certain amount of time since the last image was taken, and there's 4 images that get shown, and then it goes back and it loops. So over and over and over again. Now some of these look like fish in a barrel, like super easy to get, right? But yet, we had never found these before. Citizens gave them to us. We then are responsible for looking at them and making sure that they would make sense as a good target, following up on them, and we have made some really exciting discoveries. I'm going to tell you about a couple of them now to get you psyched to participate with us. So one of them, now you're going to see one that's a little bit harder to tell, is this object. So look at it on the left. The right is a science plot that I'll explain to you in a second. But focus on the left one for a second and tell me if you can see the blinking object. It's a test of eyeballs because my eye can't always see what the citizens have discovered. You should see the blob. I don't have a laser pointer. Do I have a laser pointer? Maybe I have a stick. Can you see it? I can't give it to you. You just have to believe me. Use your eyes. It's there. It jumps from kind of the middle and then it comes down. But the pixels, it's really hard to make it out. So this is one of our first that it was like, ooh, what's this? This could be as cold as that other one I told you about. It could be as cold. And this is a plot we made of it in order to get follow-up time using the Spitzer Space Telescope, the Hubble Space Telescope, and coming up this season, the James Webb Space Telescope is going to observe this object. Citizen scientists discovered. And this is a plot that shows you the color of an object versus how bright it is. And this here is that object that I started this talk with, that cold one, that frigid one that we're so excited about. And this object called 0830 is very close to it on this plot. So it might very well be the same kind of object as 0855. But the only way we get to know is if they let us use a telescope and follow up on it. So we followed it up with the Spitzer Space Telescope to verify it stood the test. It was there and it was moving fast. We followed it up with the Hubble Space Telescope and it also said it's very cold. And then that let us justify the James Webb Space Telescope that's going to allow us to open up the hood on it and look at what's in its atmosphere. That's upcoming in the next probably 2 months. We'll get that observation. Here's another one. This one you're really going to have to try and see the one on the left-hand side. Oh, actually, the left-hand side one's okay. The one on the right-hand side is a tricky one. Both of them have an object jumping in between images. Let your eyes focus. So this object, the one on the right, we call the accident because we accidentally discovered it. It was in an image with another object that somebody had given us to look at, and then we saw that this one was also moving. Total coincidence. But this thing is like an alien spaceship. It sits on this diagram, not in the place that 08, so there's 0830, the one I was just telling you about. This one is that cold one, 0855. This one called the accident sits in a plot where no one else lives. So while we didn't think we found another 0855 clone, that cold object clone, we knew we found something super weird. And we did. We did just get data from the James Webb Space Telescope on that object, and it looked like the most crazy atmosphere I've ever seen. And the reason is that object is very cold, but it's also extremely old. It is the oldest substellar mass object anyone has ever found in the entire galaxy. It is coming in from the galactic halo, from the remnants, probably, of the earliest parts of the Milky Way. And when we saw the spectrum of it, when we saw the data come out of the James Webb Space Telescope, it basically had no metals in it, because anything born in the earliest parts of the galaxy weren't around for that epoch of the metals forming. So it was really exciting to get this object. Again, a citizen scientist discovered it. Now, we didn't find anything yet that's as close as the closest star, but we're really finding good stuff. Here's another one. This one is one of my favorites. So you see the bright star blinking, right? Now just look up to the top of the bright star and just a little to the right of it. There's another black dot jumping with it, back and forth and back and forth. So there's two objects jumping in this particular image here. And so that black dot is a low mass brown dwarf. Now, it's not orange like the other ones I was telling you because it's warmer. But the thing is, you see how it's close to the spike of the star? So it's near what's called a diffraction spike of that image, which meant everybody missed it. Now, this star was looked at by multiple teams trying to find a planet around it. What they were doing is direct imaging by blocking the light of the star and searching for a planet. This, we just had a citizen scientist find. It's very widely separated from the star, but it is the exact kind of planet they were looking for in the exoplanet study because that's a young star. That's a star that's just a couple 100 million years old. We estimated it at roughly like 200 million year old star. And that object bouncing back and forth is just a couple times the mass of Jupiter. It's orbiting the big bright star there, but it was missed by all of the other teams because it's too far outside of their field of view and no one looked near the diffraction spike of the star. But citizen scientists discovered it. Okay, last things on this. I just want to show you some articles on some of the work that our team has been doing. We have thousands of objects that we've discovered. I'm not going to tell you, we haven't found one that's as close as the other two Kevin found. It's fine. Kevin Lumen did what he found those two objects, and we haven't found anything yet that's as close as them. But I'm not giving up. I think they could still be out there. But we have found these crazy objects. This was an article that NASA wrote because we won James Webb Space Telescope time in the first cycle with our citizen scientist volunteers as co-eyes, co-investigators on our proposal. They participated with us. They were on the winning team. They got to see that data first. You guys could be one of those people too. It was really exciting to invite them in on those first looks at the data because they had found the objects. I led the proposal. I invited them on to the project. So NASA was really excited. They wrote an article about it. This is another one that was really exciting. This is once we started getting the Webb data, one of the other ones that our citizen scientists had found. It's close. It's like, I call it still spitting distance away. It's very close to us, this object. But the weird thing was when we followed it up with the James Webb Space Telescope and we looked under the hood at its atmosphere, this particular object that this study was about revealed something very strange going on. Now, there was no way we could know about it unless a citizen scientist had revealed it for us, but there was no way even in seeing it from the citizen scientist we could have known how good it was. It was kind of serendipitous that this happened, but this is a citizen scientist discovery. And it had this weird emission feature that is due to, we think, an aurora that is going on the object. Now, aurora, okay, so we have them on Earth, we have them in the solar system, yes, but we get our aurora largely from the sun, because the sun has a lovely plasma that it sends our way that interacts with our magnetosphere, and we get beautiful glowing aurora, right? But in this case, it's isolated. There's no sun to provide the aurora. So what is it, an alien megaship? No, we didn't go there. You can get an aurora from something else. Jupiter has another contribution, and it's from its active moon, Io. So in this case, the citizen scientist discovered object that we got James Webb Space Telescope to follow up on looks like it might, possibly, we speculate, have a moon around it. Another result, this is this object I told you is called the accident. This just came out, this paper came out last month in September. We found that it's so old, this 10 billion year thing. I told you it has no metals, but then we saw a molecule that no one's ever seen before in a planetary atmosphere. It's called silane. Si, silicon, and 4 hydrogens. So we discovered that these very old objects, like hydrogen, they're in hydrogen-favoring atmospheres rather than oxygen-favoring atmospheres. Super exciting result. It just came out. Another citizen science discovery that just led to revelations in astronomy. And then a couple of celebration things I want to show you from our project. One of our really just like amazing super users is somebody named Dan Castleton, whose full-time job is a securities guy for a company in Massachusetts. He helps them make sure nobody steals their cybersecurity, so they won't steal their information. He's really good with computer science, but you don't have to be. He's just also got really good eyes. So Dan's done so much with us that the American Astronomical Society awarded him the Chambliss Amateur Achievement Award. He got a plaque. You could get a plaque. Okay, last things. We use this with kids. I heard somebody earlier asking, like, oh, how could I use my citizen science project with kids? I work at a museum. I work at the American Museum of Natural History. I work with kids all the time. I've presented Backyard Worlds to kids from the littlest ones. There's probably 3rd grade is where I would start us at. 3rd grade through high school, undergrad, grad, everybody else, great. But on the right-hand side is me presenting with a bunch of kids in New York. On the left-hand side, another one of my colleagues was presenting it at a classroom in Canada. And then at the American Astronomical Society meeting 3 years ago, we held a special session. And another thing you get to do when you become a super user with us is they got to come to the meeting and participate in a special session. So 4 of those folks that are in this picture that were a part of this panel in front of a room full of probably like 70 astronomers that wanted to hear them talk were 4 volunteers from our project. So I'm very passionate about this project, as you might be able to tell here. I want to find an object closer than Proxima Centauri. I want maybe you to help me find said object. So my conclusion is that you could participate too, and you could help unlock the solar neighborhood. There is certainly more to discover, and even if we don't find the next closest object, as you can see by my examples there, you can find some really amazing objects. So with that, I'll stop and take any questions that you guys have.
All right, if you have any questions, please just raise your hand. We'll run a mic over to you. It's okay. You guys need a second to think. I know. It's been a long day, but a really fun day, hopefully.
You can ask anything, even about aliens, if you want. There's a question in the back there.
The solar planet, how do you know if it's going to remain at 7,000 light years, is it on a trajectory that's parallel or going away from us, closer to us?
7 light years, the 0855 object that I was showing you. I'll just go back to it so that we all remember, because I did blink it fast. This object, that's 7.27 light years away. So we measure its distance, we measure its parallax, and it's pretty easy, relatively easy to measure the distance to an object that's that close, believe it or not. 7 light years is spitting distance away from the sun. You use basically the distance between the sun and the Earth as it's orbiting in order to take images. You take images all along the way. Is this not your question?
The trajectory, is it moving away from us, closer to us?
Oh, okay. How is it moving? It's moving very fast, but it's not towards or away from us. It's on some vector. But you ask an interesting question, because we have a side project that we've been doing, because if something is close to you, but has basically no motion, like you're not seeing any of the proper motion, but you know it's like 10 parsecs away or 30 light years away, there's only one way that it's going. All that motion must be locked into its radial velocity, so it's either heading for you or heading away from you. And so I've got a side project that I call Solar System Disruptors, and that's searching for objects that we use the parallaxes from the Gaia telescope, and we look for the ones that are super close but have zero proper motion. And then I'm going after their radial velocities to see who's coming at us or going away from us. And the citizen scientists that are a part of Backyard World are working with me on that as a side project. So we do a lot of these side projects with our super users. So they're helping me identify the candidate lists. None of the ones that they've discovered are like that, because by its very nature, we want them to have motion in the lateral direction. So they can't be coming towards us or away from us to disrupt us.
I noticed on one of the earlier videos that you had of this, the planet moving, that one of them appeared to move in front of a star, assuming those black dots are stars.
In one of my...
Yeah, you had several thumbnails. Yes, there it is. Row 2 all the way to the left. When it starts, it looks like it passes right in front of that star.
Yeah, so that can happen. Can happen. You mean
from
like...
that, could you glean any information about its atmosphere?
No, so that is basically because the star, the black star, is not moving, right? Because it's too far away. And then our object, but you'd have to, there's a method of micro-lensing that people want to see, it has to get so close to that other star. These are huge pixels that you're seeing right now in this image, because the Wide Field Infrared Survey Explorer had like 1 arcsecond pixels. So it's not usable for what you're thinking, which is a good idea.
Okay,
but you need smaller
I was just
pixels.
curious if that starlight coming through, obviously you could read something about the atmosphere of the planet.
Yeah, you'd also have to do it exactly when it went in front, and this is just happenstance that it's passing nearby. And these are our discovery images anyway.
All right. Any other questions? Perfect. Okay, please thank our speaker once again.